In this video, I'd like to talk about graphing linear equations again, but this time in standard form. So the first question I want to ask ourselves is, well, what is standard form of a linear equation? We notice that standard form of a linear equation is this form right here. ax plus by equals c. I still have an x term, a y term, and some other constant term, but this time x and y are on the same side of the equation, not like our slope-intercept form, which we've talked about before, where the equations actually solve for y, or in other words, this y equals mx plus b form. So in the past, we've learned that we can solve for y and just simply put any equation into y equals mx plus b form, and then we can graph the equation from here. The question I'd like to look at is there an easier way, or at least is there a different way that we can graph these standard form equations without having to simply put them into mx plus b form? And the answer is yes. What we can simply do is find both the x and the y intercepts. Now we've already talked about what the y-intercept is, so what I'd like to do then is talk about what this x-intercept is, and then we can look at how we can actually find both of these intercepts. So first of all, the x-intercept, very similar to our y-intercept we talked about earlier, is the point where the line crosses the x-axis. So quite simply, if I look at this line here, I notice that there is one point where it crosses this horizontal x-axis, and in this case that occurs right at this point -1, 0. So that's considered our x-intercept. The question now is, well, how do I find the x-intercept and the y-intercept, and how can we use those to graph? Well, first of all, if I can find both this point, the y-intercept, and this point, the x-intercept, I notice that I can only draw one line that perfectly goes through both these points. So if I can get both the intercepts, we can draw a line through them, and then we've basically gotten a pretty good graph of the equation. So the question is, well, how do I find these intercepts? Well, let's start with the y-intercept. I notice that anywhere on top of the y-axis here, I have not moved left or right at all. That means any point on top of the y-axis has the point x equals 0. So, very simply, the y-intercept is located on the y-axis where the x value is equal to 0. So, how can we use this information to help us find the y-intercept? Well, it turns out if we know x is 0 no matter what, we can find the y-intercept by plugging in. So, plugging in x equals 0, and then after we've plugged in x equals 0, all we have to do then is solve for y. And that y is going to be our y-intercept. Now similarly, we notice that the x-intercept is located again on the x-axis, and I notice that any point on top of this x-axis, since I've not gone down, has the y value of 0. So key thing here, on the x-axis, our y value is equal to 0 as well. So by the same logic here, I can find the x-intercept by first plugging in y equals 0. So the fact that I know y is always 0, I can assume that that's true for all values. Plug in y equals 0, and then all we need to do after we plug in y equals 0 is then solve for x, and that value will be our x-intercept. So let's see if we can put these two different ideas together and actually get some decent sketches of some graphs. So here's how we're going to do it. Number one, again, we're going to find the x-intercept by plugging in y equals 0, solving for x. Then we're going to find the y-intercept by plugging in x equals 0 and solving for y. Then we're going to plot both these points, and then we can simply sketch a line that connects those points together. So here's our first problem. I want to find both the intercepts of 2x minus 4y equals 8 and then graph. So if you remember, I can find the x-intercept by setting y equal to 0. So as a quick reminder, I'm going to put in parentheses, x-intercept occurs where y equals 0. And again, as a reminder, that's because on the x-axis, I'm not going up or down. The y value is always equal to 0. So here we go. I'm going to plug in y equals 0 to this equation. So that's 2x minus 4 times 0 for our y equals 8. Now one of the nice things I notice is that 4 times 0 is simply 0, or in other words, this whole term here, the 4 minus 0 just becomes 0. So this literally just becomes 2x minus 0 equals 8. The minus 0 doesn't actually do anything, so if I want to, I can simply just jump to 2x equals 8. Or in other words, our x-intercept occurs at x equals 4 when I divide by 2. So now I just need to find the y-intercept, and remember, our y-intercept occurs where x equals 0, because anywhere on top of the y-axis, I have not moved left or right, and our x value is equal to 0. So I can simply plug in here our x value equal to 0. So this time it's 2 times 0 minus 4y. Notice I'm plugging in for x this time. I know that the whole 2, 0 term just becomes 0. So in other words, I'm now just left with negative 4y equals 8. And if I now divide by that negative 4, I'm just left with y equals a negative 2 for my second intercept. So now I can plot these 2 points pretty simply. My first x-intercept is at 4, so notice on the x-axis I'm going to move to the right 4 and plot that point right here at x equals 4. And then my y-intercept was at negative 2, so I'm going to go down 2 here and plot this next point here. And now that I have these 2 points plotted, this is enough for me to sketch my line, and I can say, well, it looks to me like we have a general line that looks something like this. Now, as we're still learning, if you're not confident in your graph that you found the intercepts correctly, remember you can always actually find the y slope-intercept form of this equation by solving for y if you would like to. So just as a quick check, we can do this if we'd like. So if I take this 2x minus 4y equals 8, I'll do that up here in quadrant 2. So if I take the 2x minus 4y equals 8, if we want to check our work, I can subtract 2x, giving me negative 4y equals negative 2x plus 8. And then I can divide by a negative 4, which you'll notice will give me y equals negative 2 over negative 4x plus 8 over a negative 4, and then simplifying those, negative 2 over a negative 4 is a positive 1/2 x minus 2. I notice pretty quickly here, well, what's my slope? Looks like the slope is 1/2 with a y-intercept at negative 2, and let's confirm that. I see that I am crossing with a y-intercept at negative 2, and I am going right 2 up 1, or in other words, a rise of 2, a run of 2, a rise of 1, a run of 2, a rise of 1. So it looks like this graph is matching our slope-intercept form. I don't need you to do this every single time, but it's not a bad idea sometimes just to check our graph by finding that slope-intercept form. So here's another example we can go through. I first want to find the x-intercept, and remember we find the x-intercept by setting y equal to 0 and then solving. Right, again, we're on top of the x-axis. I've not moved up or down anywhere on the x-axis, so my y value must be 0. So if you plug this in, looks like I'm going to have 10x plus 3 times 0 equals 15. 3 times 0 is just 0. I don't need to write the add 0. So if I want, I can just go to the 10x equals 15. And now if I divide by 2, I get that divide by 10, I get that x equals 15 over 10, which actually can simplify down to 3 over 2. That's good. Now one thing you might notice here, though, is that this is not a nice integer. We'll come back to how to plot the fraction 3 over 2 in just a minute. But for now, let's find the y-intercept first. Remember that on the y-axis, x is equal to 0. So I'm now going to plug in x equals 0, so that's 10 times 0, plus, looks to me like a 3y is going to equal 15. This will be our new equation to solve to find the y-intercept. Again, the 10 times 0 just drops away to nothing, so I'm actually just left with 3y equals 15. And then if I divide by 3, it looks like we end up with y equals 5 as our y-intercept. So we can start by plotting the easy one. The y equals 5 is easy enough to do. All we have to do is just go up 5 on the y-axis, and I know that there's my first point. Now the 3 over 2 is a little bit harder to do here. 3 over 2, it might be helpful to actually find this as a fraction, as a decimal rather. If I divide 3 by 2, either in a calculator or in our head, I know that this is actually going to come out to be 1.5. 1.5. Now why this is important is that 1.5 is exactly between 1 and 2. I can plot this on the x-axis by literally putting a point directly halfway in between 1 and 2, just like this. Now I'm not asking for a perfection when we do this point. I'm just asking for a reasonably good approximation, just to get a reasonably decent graph. So now that I have these 2 points, I can go ahead and plot the line. It looks like our line would look something like this. Good. So one more example. I'm going to again first find the x-intercept of this equation. I find the x-intercept by plugging in y equals 0. So if we set this up, the x-intercept will occur when I have 4x minus 3 times 0 equal to 8. 3 times 0 is just 0, and subtracting 0 does nothing, so I can simply jump right to 4x equals 8. Or in other words, I'm looking for x equals 2 as our x-intercept. Now for the y-intercept occurs when x equals 0. So now I can simply plug in 4 times 0 minus 3y is equal to 8. Now 4 times 0 is nothing, and I don't need to do 0 minus 3y, so I can jump right to minus 3y equals 8. And if I now divide by the negative 3, it looks to me like y is equal to negative 8 thirds. And again, because 8 over 3 is a little bit tough to graph, it might be nice to get the decimal. If I do 8 over 3 on a calculator, I might end up finding that this is equal to 2 2/3, or in other words, about 2.6 repeating. 2.6 repeating. So with this in mind, I can first plot the x-intercept. X equals 2, so I can go right 2 on the x-axis. That's a pretty easy point to plot. And then the y-intercept of 2.6, keep in mind this is negative. I almost forgot that. That is a negative 2.6. So I want to make sure I include that negative 2.6. I notice that this is telling me to go down in between 2 and 3, and the 0.6 is telling me to go slightly closer to the negative 3 than to the negative 2. Again, I'm not asking for perfection, but I'd say we could plot the point pretty well right about here. Notice how I'm in between negative 2 and negative 3, slightly closer to the negative 3 than the negative 2, but again, we're not asking for perfection, just for a pretty good graph. And this is enough now that I can sketch a decent line in between. Good. So at this point, I have 4 on your own problems I'd like you to try. First find the x and the y-intercept, and then sketching. So go ahead and give those a try, and we'll check in on this next class.